Everybody, welcome back to EE504. In the second video, I just wanted to go over the lab experiment for week 2. And this week, we're going to be building up an antenna for the FM broadcast band and setting up a FM receiver on the Pluto radio. So just in the assignment document, we've got some background on antenna theory and why our, bunny ear antennas don't necessarily work well for the FM broadcast band. And then we talk a little bit about how to build a monopole antenna and just some equations to calculate the length of your antenna, for a quarter wavelength, and how we would simply use an SMA connector, attach the conductor onto the pins of that SMA connector. So let's actually take a look at what the SMA connectors look like. I'll go ahead and bring a bunch to the lab, and I'll bring some copper wire, and so we can have a time there. So SMA connector. So these are what the SMA connectors look like. I'll be bringing in these male connectors, right? So these attach directly onto the Pluto, and then this is like a good picture of what the other end of that, where we attach the actual antenna to. So in that center conductor, that's where we attach the radiating element, and then on the outer 4 pins is where we would attach a ground plane if we wanted to. And so, like I said, we'll be making a monopole antenna, and I'll be bringing some copper wire, so that we can bring some copper wire, a soldering iron, and all the SMA connectors that we would need. So I envision us just making one per group, unless everyone wants to make one. I think I have enough SMA connectors to do so. So this is just some background on frequency modulated signals, and that should be somewhat of a review from your previous communications courses. But in general, so you have your carrier frequency, and that frequency, of your carrier sinusoid is being modulated by, some integral amount of the message signal. And for F delta is that frequency deviation. And so the frequency deviation in the US, I think it's pretty standard for the FM band at least. If you just look it up here. Because there is a part in Simulink where you'll have to set that. So frequency deviation FM band in the US. I want to say it's about 75 kilohertz. Yeah, okay. So about 75 kilohertz. So that's something that's good to know. Also new this week is that we're going to be using Simulink instead of MATLAB. So you go onto MATLAB actually and go to the home tab. If you have Simulink installed, it'll pop up here. Otherwise, you'll have to go onto the add-ons, get Simulink, and good. So once you open up, once you click Simulink here on the home tab, it'll open up an Explorer, and you'll want to hit open blank model. So that will open up something that looks like this. So in here, this is kind of like your workspace. And if you don't know what you're looking for, you can click on this library browser, and it'll open up a place where you can navigate all the different things that are available in Simulink. That might take a while. I guess I haven't opened it in a while. Anyways, so we'll be using Simulink. I'll be sure to outline all the different blocks that you'll need. I haven't completely finished this write-up quite yet. And then again, we're going to be looking at the spectrum analyzer, for the two different antennas, right? So we have your kit antenna and you have your monopole antenna that you'll be building in the lab. And then as an added bonus, if you have some time, you can use a vector network analyzer to look at the return loss of your antenna. And so basically, if you haven't used a vector network analyzer before, depending on what the frequency you're designing your antenna for, ideally you would want a dip around that frequency, right? So that means that we're getting kind of like low impedance, so then all the energy is being transferred back through the radiating element into your antenna there. Uh, you know, so and this is kind of like the gain of your antenna, like in dB. Let's just see if this is open back up yet. All right, so this is what the library browser looks like in Simulink. I've got a bunch of different packages installed, but I think what we would be looking for is a support package, and you've got these two blocks, so you can just grab radio receiver block, and this is taking a pretty long time. And so here there's this little message about quickly inserting blocks. So if you close this, if you know what you're looking for, you can just double click here and you can look up what block that you want. So for example, we want an FM broadcast demodulator baseband. So we can grab that block. And to edit the properties of the block, you just double click it. So you can say your sample rate, your frequency deviation, all these different parameters. And one thing to note is once we get up and running, you'll want to change this to interpreted execution. And that's just so that it runs directly in Simulink instead of trying to generate code and then flash your radio with. Um, oh, so you can be editing these parameters, trying to get your radio to receive the FM broadcast band. And so once you have it set up, I've actually got set up over here. Right, so we're tapping off once the signal is demodulated and we're looking at the frequency spectrum, and we're also outputting on the audio device. And so once you kind of have that up and running, if you look at the spectrum analyzer, so Lucas actually kind of pointed this out last week in his lab manual, but if you go up to analyzer, instead of just a spectrum, you can actually look at a spectrogram. And so what the spectrogram does is it allows you to look at the energy, kind of like over time. So this is time, and then this is the entire spectral energy. So if we run it, I don't know that you'll hear the radio, but there's a good chance that we'll see a little waterfall plot, if it decides to run. And so that's kind of like what it would look like. It would be also good to look at this picture and this pictogram. I don't know why I took that off. Um, but that's just something to keep in mind, as you're going through this. But I think that's all I had. Thanks for tuning in. See you guys in lab tonight.